we are going to look at timing diagrams for JK flip-flops. This particular JK flip-flop, and you're familiar with this already, has an asynchronous set on the top and a reset or a clear on the bottom. And you know these are asynchronous, so if I send in a 1 on the top, it'll set output Q to a 1 immediately. If I send in a 1 on the bottom, it will make output Q a 0 immediately. So when I fill in this timing diagram, that's the first thing that I want to look at. Now here on the top, it just shows a clock signal going from 0 to 1, back to 0 to 1. And I know that, again, set and reset do their job immediately. So I'm just going to look along here, and I see that at the end, I see set goes to a 1. So I know that my output Q is going to go to a 1 at that particular point. So let me just mark that up here. I'm filling in a 1 for output Q. And actually, let me look at reset while I'm at it. I see that reset is a 1 at the beginning. That tells me that Q is going to be a 0, at least for this beginning part. So I know that it's a 0 right there. All right, let's see if I can figure out the rest of this. Now, if I look at the clock signal, I see that it's a positive edge-triggered clock. So I know that things are only going to happen when the clock goes up. That's this part of the clock. Boy, I'm drawing really messy. So I really only have to look at every place the clock signal goes from a 0 to 1. This is a positive edge-triggered clock. Let me fill in all those. Having a little bit of trouble. All right, so let's see what happens the first time the clock goes up. Well, my reset is still 1, so I know I'm at 1. The next time the clock goes up, I can see that I have J is a 0 and K is a 0. That's memory state. So I'm just going to stay where I am, right? Memory state doesn't change. The next time the clock goes up, J is a 0, K is a 1. Well, that's reset state. Well, it's not very exciting. So that means I stay at 0. Keep going till the next clock pulse. Now I see that J is a 1 and K is a 1. Oops, I guess I should have put a 1 for the last one. Sorry about that. J is 1 and K is a 1. Well, you know that's toggle mode, so I'm going to go from my 0 state to my 1 state. Keep going until the clock goes up again. Again, they're both 1s. J and K are both 1s, so it toggles again. My output Q toggles. Go to the next clock pulse here. So I have, wow, look at that. J and K are both 1s again. Really exciting. It's going to toggle again. Keep going. Now, finally, I have J is a 0, K is a 1. That is a reset state. So it goes back down to 0. One last one. Now it looks like they're both 0s. And so I'm in memory state until this set happens. And then I know that I'm going to go up to set. And that is it. That is my timing diagram for this JK flip-flop. All right, let's do one more timing diagram. This is very similar to the last one, except this schematic shows that this is an active low input here. In other words, if I send in a 0, it will preset this chip. If I send in a 0 on the bottom, it'll clear it, right? And I always look at my asynchronous inputs first because they happen immediately no matter what's going on with the clock. So let me look at set. Now, when set goes to 0, that means I'm setting Q to a 1. So I'll make that a 1. I know it's going to be at least a 1 there. And set goes to 0 right here again at the end. So I know that Q is going to be 1. Right? In this case, the little bubble means that set will do his job when he gets a 1. The little bubble means that clear will do his job. I'm sorry, when he gets a 0. Did I say 1? The little circle there means when he gets a 0, he does his job. All right, let's look at the reset. You can see reset is a 0 right here. That means Q will get reset for at least this time period. All right, now let's look at the synchronous inputs, J and K. Oh, this little bubble next to the clock means this is an active low or a negative edge. I guess I should say negative edge triggered clock. So stuff will happen when the clock edge goes from 1 to 0. Right there. Right there. Every place the clock goes down to 0, that's when stuff's going to happen. I hope I'm marking the right places. I'm trying to go quick. All these places where the clock goes down, stuff's going to happen. All right, let's look at the first case. Well, nothing happened here because I'm still being set. So this case, I have J as a 1 and K as a 1. That's toggle mode. So if the clock, if Q is up, it will now be down. Of course, it toggled. Now I'll go along, well, I guess I connect to this one, go along till the next clock pulse. So the next time the clock goes down, J and K are both 1s still. That means I'm going to toggle again. All right, keep going to the next clock cycle. Now J is a 1, K is a 0, so I'm going to set output Q to a 1. Well, it's already a 1, so nothing happened. J and K are both 1s, toggle mode, so I go back down to 0. Keep going along. J and K are both 1s again, so I have to toggle again. Now when I look at the next one, this time J is a 0, K is a 1. Well, let's reset. So when I go to here, I reset, I go down to 0. Keep going. I have a 0 and a 1. I'm still in reset mode, so it stays down here. Keep going. All of a sudden I jump up. Well, why do I jump up? Well, because I have this asynchronous set, and that's it. I guess it just stays up until the very end. All right, well, you have a couple to practice, and I will post some answer keys as well, so you can check your answers after you do these.